Hello guys, my name is Hossain. Welcome back to my data structure series. In the previous video, we have discussed why do we need a sparse table and how can we build a sparse table data structure. Today we will see that how can we answer any range query using a sparse table. Let's see. Suppose this is an array we are given. This is an array of length 9, I guess. 2, 4, 6, 8, 9. Okay, 9. So we have to answer the what is the maximum element of any range. Okay, suppose the range is 2 to 6, so this is 2 and this is 3, 4, 5, 6, this is 6, right? So we have to tell that what is the maximum element in this range, right? So we can do it in the naive approach, we have seen that, but here the problem is the size of the array can be only to 10 to the power 5 highest, and the queries can be at most 10 to the power 5 also. So if we do it in each query, so it will get TLE, right? So for that we have seen that we have to do some pre-processing. We have to make some block. We have to make the block of size power of 2. We will make all the blocks of power 2 from every position. In this way we will make the sparse table. We have seen that in the previous video. Now we will see that how can we answer this query by using this sparse table. So since we are making a sparse table by the maximum power of base 2 of any length, so we have to calculate the length of this range first, right? So this is actually 6 minus 2 plus 1, which is 5, right? We have to calculate the maximum power of base 2 to make length less than equals 5, right? So then we will calculate or take the maximum element of that length from this L equals to from this position that we have stored in the sparse table. So then we will decrement our length and then we will take the maximum power of 2 again. Then it is actually the binary representation of any number, you can see. So the maximum power of base 2 to make length less than equals 5 is actually this first bit, which is 0 1 2 2th bit. So this is actually 2 to the power 2, which is 4, right? So firstly we will take the maximum element of length 4 from L equals to this position. Okay, so this will be the length. So in this range the maximum element is 25, you can see. Then we will jump length 4, then the next position will be this, right? So the remaining length will be 5 minus 4 is equals 1. So to make 1, the maximum power of base 2 will be 2 to the power 0, which is 1. Then we will take the maximum element of length 1 from this position. This is actually 15, you can see. So then the remaining length will be 0, so we can't do any other move. So if we can do any other move, then we will do, but in this position length is 0, so we will not do any other move. Then you can see in this range the maximum element is 25 and in this range the maximum element is 15. So we will then combine these two solutions. The maximum of 25 and 15 is 25, right? So then our maximum answer will be 25. So in this way we can answer a sparse table. We can answer any range queries by using a sparse table. So this is the implementation. We will firstly calculate the length of the range, which is r minus l plus 1. So then we will initialize our maximum variable by 0. I have considered that all the elements of the array will be positive. If the array contains a negative value, then you have to initialize the maximum variable uh, the minus infinity, that can't be in our range. Okay, so then we will run a loop till the len is not equal 0. So whenever len will be 0, then we will break this loop. So inside this loop we will update our maximum variable, right? So firstly we will take the maximum power of this length of power of 2 actually. So this is inside the log array. We have seen what is log array. We have discussed about it in the previous video. Log array basically stores the maximum power of base 2 to make any length, to make less than equals any length. Okay. So then we will update our maximum variable by firstly we will take the maximum element from this position to this length. Okay, 2 to the power max power length. This is inside this index, which is st of l max power. Then we will take this maximum, then we will combine this with our previous maximum. Okay, so we will maximize these two and we will store it inside our maximum variable. Then we will jump this length on left shift max power, which is actually 2 to the power max power. If you don't know about left shift operator, you can check out my bit manipulation playlist. There I have discussed about all the bitwise operators and their operations. So here on left shift max power means 2 to the power max power. Okay, then I will subtract this length from our length. Then if the remaining length is not 0, then we will again go inside this loop. Okay, so we will again do the same processing. Firstly we will take the maximum power, then we will combine our maximum with the previous maximum and the current size current maximum from this position to this length. Okay, then we will again jump this amount of length, then we will subtract this amount of length from our length. We will do this till length is not equal 0. Okay, then whenever the will be 0, we will break our loop and we will return our maximum. Okay, so what about the time complexity? Here I am running a loop till the length is greater than 0. So I am subtracting the length actually on left sheet max power, which is 2 power of 2 actually, right? So I am subtracting the length by power of 2. So it is actually, it will run actually log n time, right? So the time complexity per each query is log n. So this is much optimization than our order n time per query, right? Let's see the code. So this is the code. I have taken the maximum length that size of the array can have. So then I have taken a log array and the array we will read. Then I have taken the sparse table array, which will be two-dimensional array, right? First dimensional will be the size of the array, and then the next will be the maximum power of these two. So this is the size of the array will be 1 into 10 to the power 5, and the maximum power of these two to make length less than equal to 1 into 10 to the power 5 is around 16 or 17. So this is why I have taken 20. I'm initializing the logger inside this function. I have discussed it in the Sparse Table Part-1 video. I have discussed it also in the Sparse Table Part-1 video, which is building a Sparse Table. Firstly, I am initializing the block of size 1 of Sparse Table, which is the element of that position itself. Then I am initializing all other blocks by the previous size. I have discussed all of it in the previous video. I am not going to repeat it. So then I am doing this query that I have discussed in the previous slide. Then inside the main function, firstly I am reading the size of the array, then I am reading the elements, all the elements of the array, then I am initializing the log array with this uh, size of the array and building the sparse table. This is all about the pre-processing stuff. Then I am reading the number of queries inside every query. I am reading L and R, which is the segment or range I have to answer. I am taking the on based indexing. For that I am reducing it to zero based indexing, because I have built the sparse table by zero based indexing, right? So then I am just print out query of L and R. So let's run the code. Suppose I am taking 8 length array, firstly 1, okay, 5, 6, 7, 8, okay, 8 value. Then I am going to take this much of query, sorry, okay, I am running it again. I'm copying it and paste it, okay. Then I am taking this much of query. Then first of all, let's see the whole array maximum whole range. So this is 25, you can see. Then suppose I am taking the maximum of range 1 to 3, 1 to 3, which is 24, you can see. Then I am taking the maximum of suppose 3 to 4, you can see 24 it is. So then suppose I am taking the maximum 4 to 8, and which is 25, you can see. Then suppose I am taking the maximum of one element, is 4 to 4, which is 21, you can see. Then I am taking the maximum of suppose 6 to 8, so which is 8, you can see. So all seems to be fine, I think. So but what if in this problem constraints are something different, such as n, the size of the array is similar, which is again 10 to the power 5, but the number of queries can be at most 10 to the power 8. So this is huge, right? So if you do this log n time per each query, so then you will get TLE, right? Because we know that in 1 second we can do at most 10 to the power 8. So if you have something like the time limit is 1 or 2 seconds, something like that, then you will get TLE. Obviously you will get TLE, right? So you have to do something like constant time operation for that. So how can I do it? You don't need any other data structure for this. You can do it by Sparse Table. We will see that in the next video. So this was all for today. Till the next video drops, keep practicing, and thank you for watching.